Hello OPs, and welcome back to the OpHaxor YouTube channel. Today we're going to go over another LeetCode problem, number 223, rectangle area. So this is a shape problem. We're going to be doing area. This problem is not going to have any recursion associated with it. It's a geometric problem, and that's what we're going to be exploring today. All right, so let's get straight into it. Go over the problem statement first. So, find the total area covered by two rectilinear rectangles in a 2D plane. So it is 2D, we're not doing 3D shapes in this problem. Each rectangle is defined by its bottom left corner and top right corner as shown in the figure. So for this leftmost rectangle right here, we are given A, B, C, and D. So A is the x-coordinate in the bottom left, and C is the x-coordinate in the top right, B is the y-coordinate in the bottom left, and D is the y-coordinate in the top right. And then same thing for the rectangle here on the right side. E and G are the x's, F and H are the y's. So, and then this example input here from the LeetCode website is that shape. And if we run the program on this problem, then you get an area of 45. Alright guys, now let's jump straight into our solution. We are now in our Eclipse IDE. Our solution is in Java, and we're going to do a debug of the problem with the whiteboard in the bottom right to figure out how this solution works. So this is the solution that we have on the OpHaxor website. The article for this problem is in the description. Be sure to visit it if you have any questions. All right, so let's debug this. So first you can see I have my main method. Here are all the variables, and this is the same example problem that is given on the LeetCode website. So I pass all of these arguments to our compute area method, and we're going to go into it. All right. So the first thing that we do is we calculate, or we check to see if, so we have the partial interexist function. So what's going on here is first we pass all of our x values to see if there's a potential intersection with the x values. And then we pass in our y values to see if there's a potential intersection there. So in the first call to that function, I'm going to use the whiteboard here. We're passing in this, 0, and 9. So in the first function call of partial interexist, we're going to go into it. You can see the values here in the debugger. Now, in this first call, upper one, which is C, is being compared with lower two, which is E. If C is greater than E, we can see that there is a potential overlap here, right? Now, the next question is G greater than A? Well, it is. So with this information here, we know that the right side of this shape, and this is just the x values we're talking about, the right side, this shape, but we have an overlap because C is greater than E. So let's run this and you can see that the return value was indeed true. Now let's go into the second call for this. Now this is going to be the y values. So I've reset the whiteboard. So these are the values we're comparing now. Alright, so the first comparison is upper one, which is h. We're going to see if h is greater than lower 2, which is b. Alright, so h is 2. That is indeed higher than b. And you can see that's the intersection. Now, the second question is upper 2, which is d. Is that greater than f? And it is. Same thing with the other one. These two together show that there is an intersection when it comes to the y's, right? So this one tells us that this is the top shape and this is the bottom shape, and h, and because h is greater than b, we know that there is an intersection when it comes to the y values. So let's run that. And again, we can see that it is true. Now, these both have to be true for us to know that there's an intersection. If only the y's, if the y intersects and the x doesn't, then the shapes just won't intersect. So they both have to be true for us to know that there is an intersection. So now what's the point of even finding out if there's an intersection? Well, if there is an intersection, then we're going to find the intersection area, right? If there is no intersection, then the intersection area is 0. Okay, so since we do have an intersection, we're going to be calling the find intersection area function. And now we're here. Okay, so in this function, we're finding the area right here. And the point of doing that is after we get the result of this, we're going to find the area of this whole shape and then the area of this whole shape, add them together and subtract this part. So that's why it's useful. So this is going to take advantage of the math.max and math.min functions. So first we do math.max of a and e, which is 0. Then we do math.max of b and f, which is 0 again. Then we do math.min of c and g, which is 3. And math.min of d and h, which is 2. So you can see 0, 0, that is this point right here, and 3, 2 is this point right here. So we're finding this area, right? And we're going to go into that function. All right, so we're in the function and we can see, yep, it's 0, 0, 3, 2. And to actually find that area is we just have to subtract the y's, subtract the x's, and multiply them together. Standard geometric area. And we see that the area for that is 6. So I'm going to erase this. The area here is 6. So we return that. So int area is 6. And now, this is where it gets pretty simple. We find the area of the first rectangle. Then we find the area of the second rectangle. We add them together. And then we subtract the intersection area. And that way we get the actual total area. So let's see what those two areas are. We're going to step in and return. We can see the area of the leftmost rectangle is 24. And we're going to step into the next find area. And we can see that the area of the bottom right rectangle is 27. We can see that in the return value in the debug variables. So what we do is simply add 24 and 27 and subtract 6. So we get 45. That, of course, is our answer. Well, I hope you guys enjoyed this problem. It's not too bad once you really look into the geometry of what's going on. If you guys want to see more of our LeetCode solutions, be sure to visit our website at OpHaxor.com. I have the article for this problem linked in the description. Be sure to like and subscribe. If you have any feedback or questions, make sure to leave a comment. And I hope you guys have a great day.